Hi, I'm Christopher Marland, a Snowflake Solutions Architect here at Aimpoint Digital, an elite Snowflake Services partner. And as some of the eagle-eyed among you may have realized, I'm also a Snowflake data superhero. Now, let me introduce you to Snowpark for Python. You may have realized that there's a lot of talk about Snowpark in the data world, and that's unsurprising. It is a big part of the data cloud offering, transcending multiple workloads. But how do you use it? That's what I want to get you started with. In this video, I'm going to introduce you to why you should be using Snowpark, and I'm going to get you started developing in Snowpark for Python. So, how does that sound? Good? Let's go. But what on earth is Snowpark? That's a very valid question. Snowpark is essentially an API for querying and processing data that you interact with via scripting languages such as Scala, Java, and what we'll be using in this video, Python. So you write the queries in those languages. Snowflake takes them, executes them lazily, more on that later, and will convert that into SQL in the execution and give you the result. So does that mean that Snowpark's just for people who hate SQL? Not at all. There are many reasons why you would use Snowpark. First off, very good for AI and ML use cases. Secondly, it can be really good for scripting a backend for data applications. And thirdly, even if you're a humble data engineer as myself, the programming languages can offer some really good functionality for doing your data transformations. So the most important thing to start off with is that we have our Snowpark session. So I'm going to begin by bringing in the session object. So I'm going to do from snowflake dot snowpark dot session import capital S session. There we are. Then what I'm going to do is I'm going to create a function that creates our Snowpark session. So I'm just going to call this Snowpark session create. What I'll do in here is I'm going to specify some connection parameters as a dictionary. So account is going to be my account ID. My user is going to be my username. Password will be password. Role will be role. And the warehouse, I'm glad to say I'm special enough to have a warehouse named after me. So I'll bring that in there. Then I'm going to create the session. So I'm going to do session builder configs, and I'm going to use those connection params there. Dot create. Wonderful. And then I'm going to return the session, and I ought to spell return correctly. Okay, so let's run that. And what I want to do is I'll create a demo session equals Snowpark session create. There we are. I've created a session. So before we go any further, I want to explain two concepts to you. First, data frames, then lazy execution. Let's start with data frames. So what is a data frame? You may be familiar with pandas data frames if you've ever used pandas, but I want you to forget about that for a minute. In the Snowpark context, a data frame is basically an object that just collects transformation logic. You will do your transformations and it will just keep collecting that and storing that. Now, once you've finished with the development of your transformation logic, then you can execute that transformation logic lazily. And what do I mean by execute lazily? Essentially, you're going to take your data frame with all of its transformation logic, and when you're ready, you send that to Snowflake, and Snowflake will leverage its infrastructure and its decoupled architecture to do those transformations, to process those transformations, and then it will send you the result. That's what I mean by executing lazily. It's not going to be executed on your machine or wherever you are hosting this script. It's going to be using Snowflake in order to do the transformations. So, for those who perhaps don't believe me that Snowpark is not for people who hate SQL, I'm going to execute some SQL to show you that actually you can absolutely use SQL in Snowpark. So I'm going to create one of these data frames I told you about, and I'm going to use my session. And to do SQL on your session, you just do .sql, okay? And then you pass in the statement as a string. So what I'm going to do is I'm going to do select star from the Snowflake sample data .tc dtp sorry sf10 line item, and we'll limit that to 1,000. There we are. I've created a data frame, and that just has that bit of transformation logic. There's essentially no real transformations going on there. I'm just doing a select star limit 1,000. So what I'm going to have to do is I'm going to have to do that lazy execution now. So the two major ways of executing your data frames transformations lazily are .show and .collect. Now, .show is going to do what it says on the tin. It's going to show you your data frame. It's going to show you the results of your transformation logic. Think of it like a print statement for a data frame. And then collect is going to collect essentially. And what that means in practice is that it's going to grab your result row by row and give you a list of row objects, with each of those row objects having the specific value for the specific columns. So let's have a look at those two methods in action. So I'll do df.show, and you can see I get essentially a printed version of the result set. And because I'm using Visual Studio Code, I can scroll from side to side, which is a revolution. Let me promise you, not everybody allows that, not every IDE that is. And to collect, again, very simple, df.collect. And you see I get a load of rows there. What I can also do is I can loop through this in a for loop, for example. So I can do for row in df.collect print row, and that's going to look very, very similar. But for these rows, what I can do is I can specify a particular column. So you can see this L quantity here. And there we go. I just get the quantity there. And that's essentially it. They're both very simple ways of executing lazily. So let's start having some fun. Let's start actually doing some transformations. So what I'm going to do is I'm going to do some more imports. First, what I'll do is I'll import some functions. So I'll do snowflake.snowpark.functions, and I'll import them as f. And then, and you'll see why in a minute, I'm just going to bring in date time from datetime import date. Wonderful. Okay. So now instead of having to write out the database and the schema each time I do transformations, I'm going to point the session to a specific database. So how I'm going to do that is I'm going to do demo.session.useDatabase, and that's going to be as a string Snowflake sample data. And I'll essentially do the same thing, demo session dot use schema. And I'll point that to this tpch sf10. Okay, so let's run that. There we are, that has worked. And I'm going to say, okay, I want my data frame to point to a specific table. And that's going to be a line item. And now I've done that, I'm not going to need to do the demo session dot. That's done now. And what I want to do is I want to select some specific columns and filter those columns. So to do that, I want df equals df dot select, and I'm going to list the columns that I want to select here. So they are ship date, L extended price, L ship mode, L quantity, and L discount. Okay. So that's going to select just those columns, but I also want to filter the ship date to just dates in 1997. So the way I'm going to do that is I'm going to just do dot filter at the end of that. We're just going to chain these commands. And what I want is f.col. Col is referring to a column. L ship date, do dot between date 1997 1 1 date 1997 12 31. Okay, so what that's doing is it's just saying this column ship date should be between these two dates. So I'll run that, and I'm just going to look at the result, df.show. And here we can see these dates are pretty comfortably in 1997. Cool. So what next? So next we want to create a total revenue column. We actually want a new column. So the way I'm going to do that is I'm going to again say data frame equals data frame.width column. And first I have to specify the name of that column. So I'm going to call that revenue. And then what I'm going to do is I'm going to put in the logic for that. So that is f.col. We can see that logic here. So we want to say the extended price minus the extended price times a discount, and then times that by the quantity. Okay, so here I'm going to put L extended price minus brackets f.col L extended price times f.col L discount, and I'm going to times that by f.col L quantity. Okay, let's run this now, and that seems to like it. So we'll do f.show, and do feel free to pause the video here and just catch up, because that is quite quick. There's no shame in pausing. f.show or df.show. And there we can see the revenue column now exists on the side. Cool. So what I want to do now is I want to create a new data frame called total 1997, which groups by the ship mode and gives us the total revenue by ship mode. So I'll do total 1997 equals, and I'll do that with df.group by. In there, I'm going to put the column that I want to group by with. That's L_ship mode dot ag. So this is going to do my aggregation. F.sum revenue. And the one thing I'm going to do as well is I don't want my column to be called sum revenue. So I'm just going to, after sum, I'm going to chain in a dot alias. And that in there, I'm going to give the name of the column that I want. Alias total revenue. And so look, total 1997 dot show. And there we are. We are negative in all of them, which is not very good, but there we are. That is how we do some of those basic queries in Snowpark. So let's have a look at performing joins. So what I'm going to do is I'm going to uncomment this pre-written code I've got here, and this just creates another data frame, df2, which basically looks at 1998 instead. So we're filtering to 1998, and then we're creating a total 1998 data frame, and that total revenue column is called total revenue 1998. So what I'm going to want to do with our total 1997 data frame is I'm going to want to rename that column. So the way I do that is with column renamed, and I want to give the column to be renamed. So that's total revenue, and the name of the new columns, that'll be total revenue 1997. And I'm just gonna put dot show at the end of this before we assign this to the data frame variable, because I just want to check first. So let's do dot show. Yep, that's working. So I'll get rid of dot show, and we'll say total 1997 equals just before this expression, and rerun that. Wonderful. So now that I've done that, I want to actually do this join. So what I'll do is I'll do total 1997 dot join. And the first thing I want to specify is the data frame that I'm joining to. So that's total 1998. And I then want to say, how am I doing this join? So that is total 1997 dot L underscore ship mode equals total 1998 dot L ship mode. And that's going to do that join. So I'm just going to do dot show here. And there we are. We have something that looks a little ugly, not exactly what I want, but we can deal with that in a minute. So I'm going to do a dot select statement after this. And what is really clever about our dot select statement is in this, I can reference the column names according to their sort of parent data frame. So I can say total 1997 dot col, or L ship mode, and I can then alias this L ship mode, and that's going to get rid of this this at the beginning that you see on the column name. So I'll do total.1997.col. I want that total revenue 1997 and total.1998.col total revenue 1998. Okay, so let's have a look at that. I'm going to do dot show again to have a look at the result. And there we are. Cool. So I'm going to get rid of that dot show, and I'm just going to call this joined dfs equals, might put an underscore there instead, joined underscore dfs, and we'll run that. Wonderful. We now have our two data frames joined together. So when developing in Snowflake with SQL, you are probably aware that there are lots and lots of functions that you can use, and Snowpark's no different. We can use many of those same functions, and we're going to create 3 columns with those functions. So what I'm going to do is I'm going to just create some brackets. I'll type some brackets here. And the reason I'm doing that is it just means it's a bit easier to format when you're kind of doing multiple chained expressions. So I'm going to do join dfs dot with column, and our first condition is that we just want to create a column that puts 2 totals into an array, or the 2 totals in an array. So I'm going to call this totals. If you remember, the first parameter of with column is the name of that column, and what I'll do is I'll do f dot array construct. One of those functions, basically array construct, just creates an array with whatever you put inside. And I'll do f.call total revenue 1997 f.call total revenue 1998. At the end of these brackets, I'm just going to do dot show so we can see the result of that. There we go. We have totals with those 2 values in an array. Wonderful. So what I'll do next is I'll chain a with column expression on, and I'll look at our next specification. So create a column that adds a comment specifying who created the logic. Wonderful. Okay, so I'll call that comment, and I'll do f.concat, which concatenates 2 things or many things together. And what I want to do is I want to add a literal value. So to do that, I have to do f.lit logic was created by space. And the next thing I want to put in there is f.current user. And that's one of those context functions that's just going to return who the current user is. So let's run that. There we have comment logic was created by Christopher Marland. That's me. And then I'm going to do with column again. And what I'll do is I'll look at the next condition. So create a column that says that the trust level of reg air is 40%, and for all other ship modes, it is 100%. Okay, so let's call this trust level. And we're going to have to do something analogous to a case statement, which is f.when, f.call, l ship mode double equals reg air, comma 0.4. So when this condition is true, then this. And that is how you build a when statement. And I'm going to do dot otherwise. I could do another dot when, but I'm not going to in this case. But it's always a chained expression. So it would be dot when followed by dot when followed by dot when, and then eventually dot otherwise. But dot otherwise, I'm just going to put in 1. Let's have a look at that. Okay, so we have ones, 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 and we can't see the reg air. So opening text editor, there we are. We can see reg air is 0.4. Okay, so now that I'm happy with that, what I'm going to do is I'm just, before those first brackets that we had, I'm just going to put join dfs equals. Don't run it just yet. Get rid of the .show first. A lot of trouble can be caused by that, because if your variable equals xxxx .show, it will return none. Okay, so if you've already run it and you're wondering why it's saying this is a none, it's because you ran it with .show. So you're going to go back and reconstruct the data frame. Okay, that's fine. And then I need to drop the columns total revenue 1997 and total revenue 1998 because I don't need them anymore. So to do that, it's just joined dfs dot drop f dot call total revenue 1997, and then I'll chain another dot drop on top of that, f dot call total revenue 1998. The dot show on that to see what that looks like. Remember to put the dot show at the end. There we are. That's exactly what we wanted to see. Okay, so I'll go to that dot show and joined.dfs equals. Make sure that we have that logic saved. There we are. Okay, so now for the easy bit, we just want to close our session. I'm just going to do demo session.close in capitals. And that, and there we are. So if I now try to do, say, demo.session use database, and I'll use my own, Christopher Ireland. If I try and run that, that's going to fail. And the reason cannot perform this operation because the session has been closed. So that's the error message we did want to see. So congratulations on getting to the end of this video. You've now started your journey to becoming a proper Snowpark for Python developer. If you enjoyed this video, please do like it, and please do subscribe to our channel. This is part 1 of a 3-part series where we will be delving deeper into the Snowpark for Python world. We'll have an intermediate video and an advanced video. So please do watch out for those, and please watch, and thank you again very, very much for watching this video. Goodbye.